Next problem is construct a Muri machine that take binary numbers as input. So our inputs are 0 and 1. Okay, binary numbers as input, that is sigma equal to 0, 1. And that produces residuo modulo 3 as output. Residuo modulo 3 means after dividing by 3 you will get some remainders. So we are dividing an input string by 3, it will produces the remainders 0, 1, 2. Okay, suppose if you are residuo modulo 4 means we are dividing the input by 4. We are dividing the input by 4 and we will get some remainders. After division we will get remainder. So if modulo 4 means it will produces the remainders 0, 1, 2 and 3. 4 remainders it will produce. If it is modulo 5, it will produces, if it is modulo 5, it will produces the remainders 0, 1, 2, 3, 4. 5 remainders it will produce. So modulo n means n remainders. So this is a case, residuo modulo 3 means remainders after getting divided by 3. So the possible remainders are 0, 1 and 2. Okay, so our output alphabet is, remainders are the output, right? So output alphabet is 0, 1, 2, already given the input, that is binary number. So binary number means it's a combination of zeros and ones. So sigma equal to 0, 1. Okay, so in case of binary number, if it is divisible by n, then there will be n states in DFA. Okay, if it is divisible by 3 means the DFA consists of 3 states. If it is divisible by 4 means the DFA consists of 4 states. Okay, so in case, so this is important thing. So if you are getting a problem about the binary numbers and you are asking to draw a deterministic finite automata, then if it is divisible by n, then in the DFA you should have n states. If it is divisible by 2 means in your DFA there will be only 2 states. Okay, divisible by 3, here it is residuo modulo 3, mode 3. Mode 3 means mode n. Mode n means n state. So modulo 3 means 3 states. So here in your DFA, while you are drawing DFA, you will get 3 states, Q0, Q1 and Q2. Okay, so what will be the remainder? 0, 1 and 2. So there are 3 states, each state produce remainder. Okay, Q0, suppose Q0 will produce remainder 0, Q1 will produce remainder 1, Q2 will produce remainder 2. Okay, so divisible by n, modulo n means it will produce, in the DFA there should be 3 states. N means n states. 3 means 3 states. Q0, Q1, Q2 I am taking here. Q0 will produces the output 0, Q1 the state Q1. In Muri machine each state produces some output. Okay, so Q1 produces output 1, Q2 produces output 2. Okay, so in case of binary number you don't need to think about how to draw DFA. There is a simplest method. The only thing is just to draw the state transition table. State transition table consists of set of states and you need to show the transition on input symbols. Okay, so I already told you modulo n or divided by n means n state. Here there are, this is modulo 3, so there will be 3 states. So I wrote the states Q0, Q1, Q2. Okay, then the input symbols are 0 and 1. Okay, so the simplest method, if you are having the binary number, you need to write like this, Q0, Q1, Q2. Again start the same sequence, Q0, Q1, Q2. Okay, no need to think about the transition, diagram, everything. Just write like this, Q0, Q1, Q2, then Q0, Q1, Q2. So I already told you Q0 will produce output 0, Q1 will produce output 1, Q2 will produce output 2. Okay, so just start the state transition table and in the sequence you can write the states. Here there are 3 states, Q0, Q1, Q2, so you can fill the entry like Q0, Q1, Q2, Q0, Q1, Q2. Whenever you are getting the binary number problem and you need to draw the deterministic machine, then you can follow this method. Okay, then you can draw the automata. Q0, it will produce output 0. So Q0, comma 0. Then Q0 while seeing 0, it is moving to Q0. So self loop. Q0 while seeing 1, it is moving to Q1. Okay, then complete the diagram. Then another problem, Muri machine that takes base 4 number as input. Base 4 number as input means input consists of 4 numbers. Okay, 0, 1, 2, 3. So input symbols are 0, 1, 2, 3. Residuo modulo 5 means there will be 5 remainders. That means 0 to n minus 1. So 0 to 4. So what I told you, modulo 5 means 5 states, Q0 to Q4. So write Q0 to Q4. Then our input symbols are 0, 1, 2, 3. Okay. Then last column is output alphabet. So what I told you, in the sequence you just fill the entries Q0, Q1, Q2, Q3, Q4. Again Q0, Q1, Q2, Q3, Q4. Next Q0, Q1, Q2, Q3, Q4. Q0, Q1, Q2, Q3, Q4. Okay. Then output is, first state will produce output 0, that is remainder 0, remainder 1, remainder 2, remainder 3, remainder 4. Then complete the picture. The simplest simple thing while you are getting the binary numbers. Only in case of binary number you can fill like the sequence. Okay. So in the next video I will explain you how to design a mealy machine.